Hello and welcome to my 13th video. That's on Kubernetes. That's a technology that everybody wants to learn about, and this is the zero to pass the interview video on Kubernetes. So why Kubernetes actually? Let's talk about the VM board and like the networks and all those things. Basically what technology that sucks. So what happens if you are going with the VM board and networks? First of all, there is no private network. And if you want to create one, it's pretty hard. It's not hard, but you should have some kind of knowledge. And usually it's hard to get it right. The second one, imagine that we have three VMs, how they are going to address each other. For example, you have service 1 in VM1, service 2 in VM2, but service 3 in VM3. How they're going to address each other. Are you going to use some kind of like service mesh to say that go to that VM? Or are you going to use some kind of DNS, dynamic DNS? And what happens if one of the VMs is like lost now and you want to like replace it? Probably should have some kind of dynamic DNS in there. Again, it takes some time. Third one, for example, one of your services, you're lucky, one of your services is getting attention. For example, authentication service, or probably you have an e-commerce shop and the part that is from regarding the merchant, it's getting a lot of services or a lot of like requests. What happens in there? How you can scale in that specific service? So are you going to probably increase just the VM size, maybe to be like 64 cores of CPU? No, probably it's not a good idea. What happens if that single VM goes down? Probably you would say, okay, why not having two VMs? And if one of them goes down, still I have this one and customers can get the service. But what you're going to do between these two VMs if the traffic is coming down? Probably you need some kind of load balancer, and you don't want to like be introducing more latency. What you do, type 4 or layer 4 load balancer, it's going to be in there. And then probably what you want to do is like what you're going to do regarding the SSL. So SSL is going to be given to the system or to the IP address. What you're going to do, probably you cannot do with that load balancer, specific load balancer, because it goes to the it's layer 4 load balancer. For the SSL, you need some kind of like layer 7 load balancer. So you need to have some kind of layer 7 load balancer on top, and then there is layer 4 load balancer, and then there are your VMs. Pretty hard. I have done that actually in the previous company, and it was a big pain. It's doable. We were doing that for different regions. So we had about like 5 machines in 5 continents, to make sure that we are servicing every customer that we have. And I was doing that with the Kubernetes cluster because we had different clusters and we needed some kind of like main traffic handler on top. But anyway, in any case, if you want to go with simpler systems, still with VM you should do that. So it's not pretty preferred in there. And what happens if you wanna like build and test a new microservice? Are you going to create a new VM for that? What about the cost? So we are going to just waste about like 4 CPUs or virtual CPUs, or you are going to waste, for example, 32 gigabytes of RAM just because you are testing one microservice? Not very good use of your money and utilization of the cloud. Or you're going to share it with the production. So what happens if that specific instance is bringing the system down? Again, your production goes down. Not pretty much advisable. What if the VM goes down in the middle of the night and you have some customers in UK? Happened for me. Now I'm not going to bother. I don't want to like wake up in the middle of the night to like go and like see what's happening with the down VM. And let's see how Kubernetes is giving you good responses in here. Okay, for the first one, the private network between VMs, it's pretty hard to implement it. But Kubernetes actually runs your program in a private network. Basically, there is no security issues and private network is given to you. The second issue that we had regarding probably 3 VMs, how they are going to address each other. Actually, Kubernetes comes with some kind of dynamic DNS. So you don't have any issues in there again. The next one is pretty interesting. Do you remember that issue that I said you want to have 2 VMs, then layer 4 load balancer, and then layer 7 load balancer, then SSL attached to it? You don't need to take care of any of those ones. So it's just one line of change in Kubernetes. You just say that instead of 1 replica, I want 2 replicas, and that's it. That's what I like about it. And the next one, okay, you are making a new microservice. What you're going to do? Easy. Just create a new pod and just shoot it off into the cluster. It runs fine for you. And the last one, waking up from the sleep. Nobody likes that. Okay, you don't need to wake up. You sleep. Kubernetes will do the self-healing. Yeah. And let's talk about Kubernetes. So this is the bullshit way of talking about Kubernetes. I'm sure you have seen a lot of people like coming up with some diagram like this. Yeah, this is master node, this is node, these are nodes, we have etcd, API server. Bullshit. It's about 3 years that I'm working with Kubernetes, and it's like lately that I know what is kubelet, really. Like you don't need to know these things. If somebody is asking you, just say you don't need to do these things in the real world. And this is the bad way of talking about Kubernetes. And this is a good way of talking about the Kubernetes. Okay, what is Kubernetes? So we have traffic that is coming here inside the Kubernetes. We have some kind of resource named ingress. So ingress, like ingress, something that goes in. So we have the reverse also, outgress. And we don't talk about that one in here because we are not interested about something, traffic that goes out of the Kubernetes, at least not now. We are talking about the ingress, how clients can get into the Kubernetes and get into our pod. So we have something like ingress that is setting up with your domains. For example, mydomain.com, you have like subdomains in here, like other domains. It just works with domains, pretty easy. And ingresses, they can work with services. Do you remember I was talking about layer 4 load balancer? So services. We have some kind of load balancer service, but it's almost doing the same job for you. Services basically route traffic to the pods, and the pods are the pods of the same container. So if you have a service, basically it's routing traffic to that specific container. And another service, for example, this one is merchant. For example, microservice of yours, you have 3 replicas. There is another one that is like 3 replicas of probably your UI and 3 replicas of your backend. That's it. So what happens in here, you can have services, and if one service wants to address another service in a private network, this service has some kind of like DNS name attached to it, and you can just kind of address it. That's simple. Do you remember the part that I was talking about, the replica set? That's easy. Just change 1 to 2 or 2 to 3. That's it. No change. Easy. Okay. So where is this Kubernetes hosted? Like it cannot be somewhere in the cloud, really. Like it is on the cloud, but not really on the cloud of the air. But it's sitting on the nodes. So in the Kubernetes language, we have nodes that is basically VMs. So we have VMs that they are our compute machines, virtual machines that you can get in the cloud. And when they are connected together with this Kubernetes cluster, they form a cluster, and then Kubernetes is going to manage all of those together. So it's like you have these VMs and there is a layer on top, and then basically Kubernetes is there. You don't care about the nodes. Usually, I have never had a chance to care about the nodes, really, like to know what's happening inside the nodes and all those things. Again, this is extra things that you don't need to learn. Just know that we have nodes and there are pods inside the nodes, or Kubernetes are running inside the nodes, and basically there are pods that they are in there, and pods are your containers or your programs or your microservices. So that's it. Let's go to the next one. There is one concept that I didn't know, should I put it in, shouldn't I put it in, but I thought that it's better to put that in. because whatever you do with Kubernetes, you should know about the services and different types of services that we have. It's almost 10 minutes, hey. So we have a cluster IP that is the, I can say, the simplest way of doing services. So cluster IP doesn't give anything outside of the Kubernetes. What happens is that it's something for inside. And that is why it's like cluster IP. So it's like inside the cluster. There is an IP inside the cluster, not outside of the cluster. So we have cluster IP in here. And the cluster IP, you can access the traffic with this command, kubectl. Kubectl is the way that you're going to connect to Kubernetes basically from your machine and control Kubernetes. So you can use this command to make kubectl work as a proxy and then bring it to the port like 8080. Or port forward, that's what I do usually. I never tried this command. Anyway, that's one of the things that usually you don't do. Why? Because when you're having this kind of service or cluster IP service, usually it's matched with ingress that we have in here. Ingress is another resource that ingress, for remembering that, we have ingress. Ingress usually addresses the cluster IP service. So that's how it works. So if you want to like route any kind of traffic from outside world, it goes firstly to ingress, and then ingress finds that cluster IP and just routes it to there. So this is the cluster IP plus ingress. Cluster IP just inside the Kubernetes. When it's matched with ingress, you can address it from outside of the Kubernetes. We have two other services that you can use to add access from outside of the Kubernetes. One of them is load balancer. So what happens with load balancer service is traffic is coming in and then like going through the pods. Usually load balancer service gives you some kind of public IP address that you can use to connect to basically the pods. And public IP address, try this one goes to Google. And there is another one, node port. Do you remember nodes that Kubernetes sits on top? Okay, you can open one port in each one of these nodes so that all of them can route to one service. So when you're having node port service and you're saying that, for example, open this port 30,000, then every traffic is going to go through that. Okay, maybe you can pause and review this one again. That's the only thing that maybe you want to know more about. And that's it. Really, that's all you needed to know about Kubernetes. Let's get our hands dirty, and we are going to implement this architecture in here. Not all of it. We are going to implement just service 1 with some pods inside. And for service 1, we are going to use nginx server, pretty easy. We are going to have ingress controller. Basically here that we have ingress, we have a machine named ingress. Not machine, it's like kind of like a software that is ingress controller that controls all of these ingresses or picks them up. So we are going to implement the nginx ingress controller. That's also pretty easy. And we are going to access our system with that one. Yes, let's go and make our hands dirty. Look for part 2 of this video.